Alright, so I got this transformer opened up right now. It's a 480 Delta primary, 208 120 Y secondary. Let's go ahead and take some voltage readings. I'm going to go from H1 to H2, 481. I'm going to go H1 to H3, 487, H2 to H3, 491. And we're going to go X1 to X2, 208, X1 to X3, 212, X2 to X3, 210. Have you guys ever wondered what the voltage is from an H terminal to an X terminal?
Oh, I've done way more than wonder.
So check this out. We're going to go from H1 to X1. We're only reading 185.
Here's all the information that we have so far. It's a 480 Delta primary to a 120/208 Y secondary. Here's all your voltage readings between all the terminals. And given all this information, we can actually calculate H1 to X2 and H1 to X3. First, we'll calculate the average of the primary voltage, which comes out to 486.6. And calculate our single line voltage by taking that average divided by the square root of 3. We'll do the same thing and find the average for our secondary voltage, and I took it to 4 decimal spots, so 210.2667. And our single line voltage on the secondary is 121.3975. Then we can use the law of cosine equation to find our phase angle. We'll start by squaring both sides just to make it a little bit easier to work with. And we can start plugging in our values. This is going to be the voltage that we measured from H1 to X1. This is the single line voltage on the primary side, the single line voltage on the secondary side, and we're looking for the cosine of theta. The rest of this should be pretty straightforward. Again, we're looking for that cosine of theta. As we work through this, we get to the cosine of theta being 0.8676. Taking the arc cosine of that value, we come to a phase angle from H1 to X1 of 29.82 degrees. Simply adding 120 degrees to that value, we get 149.82 for a phase angle between H1 and X2. And by subtracting that value from 120 degrees, we get a phase angle from H1 to X3 of 90.18. Now that we know our phase angle, we can simply use the law of cosines equation again and plug in the values. Again, since we know the phase angle, you simply just plug in the values to find the voltage between H1 and X2. By simply just doing the math and working through this equation, we come to a final answer from H1 to X2 of a voltage of 390.68 volts. It would be the same thing to find the voltage between H1 and X3 using the phase angle of 90.18. Working through the equation, we come to a final answer of 306.39 volts. How'd I do?
Check this out. We're going to go from H1 to X2. We're reading 388. And then H1 to X3, 308. So what's the deal with that? Why am I getting these weird voltage readings?
It's not that you're getting weird voltage readings, it's just the vector difference of two different sine waves of two different systems. How about that math, though? I'm good with being 2 volts off. It's probably Tanner's meter anyway. Should have got a Hioki. Oh yeah, props to Tanner for wearing his gloves too. Before anybody says anything, yes, they are in date. I would have busted his butt.